Welcome to MIDAS India. Myself Abhishek Wagmare. Today we are conducting the one webinar for the RCC concrete structure, G plus 15 story, and how to get the direct input the DXF file from the AutoCAD, and how to model the entire geometry, as well as how to apply the loading and the lateral loading or the gravity load, as well as the dynamic loading, and how to get the results, how to see the results that are we today we show in this by the webinar. At the end of the webinar or in between also, if you have any doubt, you just type in a chat so that I can solve your problems. We cannot talk with each others, but whatever the doubts you have, you just type it in a chat. I just solve your problem, and at that after the end of this session we send you the recording copy of this webinar also. So don't be worry about these things. So whatever the recording is there, we send you the link. You just you just downloaded this link and you can see the same recorded copy. So in the wind design data, we are considering the basic wind speed 47 meter per second. Terrain category is 3 and building class is C. Same as in the seismic design data, dual system, special reinforced concrete structure, walls with the special movement frames in both the direction, as well as the zone we are considering 3, that is the Z is equal to 0.16, and soil type is 2, medium soil, importance factor 1, and response reduction factor is 5, or else we can consider the 3 also. And the content we are considering the geometry we can directly import from the our model, and then we directly start the how to define the gravity load, as well as the two-way one-way loading, and then lateral loads, support reactions which I check the results, then response spectrum analysis, modification factor, and model participating masses, bending moment diagram, shear force diagram, that is the normal things, and the shear wall output, how we can get directly the wall design, and the dynamic reverse generation. This is the content we are doing the today. So before I started, I just show you about the which plan we are considering. So So this is the plan we are considering. We can say that orange color, we can say it's a column. So, and in the nearby the staircase, this is the some staircase area. So nearby the staircase area, I am conducting the one shear wall. So in the both direction, both faces, we are considering the shear wall. So these are the some dimension. 1 point vertically is 1.15, 2.5, 1.5, 1.5, 2.5, and the 1.5. Similarly, in the horizontal, it's a 3 meter, 2.3, 3.3, 3.3, 3.3, 2.3, and the 2.3. Sorry, 3. So in the board direction, this is the living area, this is the kitchen and bedroom, and this is the my WC and bath. We can say it's a 200 mm sunk. So this two area, this and this, and this and this, in the four edges, this is the sunk area. So we can define the different type of the loading. So how to define the different type of the loading, that is also you can see. And this is the staircase load. We apply the directly, we can say the one-way loading on this particularly staircase area. So in this project, we are considering the column size is 300 by 600, and for the shear wall, we are considering 300 thick, and the beam, we can say beam sizes is 300 by 600, and at the plinth level, it's a 300 by 450. So all thing we are considering as per the 300 width and the in this direction. So now I directly open one my AutoCAD file. So now from the AutoCAD file, you can just identify how the building is. You can say this is the my DXF file. So the DXF file you have to prepare it yourself. So according to the your uses, can everyone hear me? Just say yes so that I can proceed further. Okay, so we start for the session. So in this one AutoCAD file, you can see the some magenta color. That is the one. This is the 2D plan. If you say the 3D view, I created the column in the 3D view also. So if you do not want, we can only delete that particularly word 3D columns. We just take the 2D plan and then we proceed for the further. In this line, you can say that or everywhere it's a normal center line we consider. So if you want, you can consider in the layer form also, so that you can directly import it into the layer forms. Now I just go to the my MIDAS. This is the MIDAS. So before I started, I just tell you about the MIDAS. MIDAS is generally, we can say it's a general product. It's not a general because of the particular things we can do. It is for the any type of the structure like the your stadium, steel, arena, plus RCC building, SRC section. The any type of the structure you can model easily and you can get the results. This is the use of the MIDAS gen. Similarly, we have the various products in the MIDAS. MIDAS gen for the building sector is the MIDAS Gen, MIDAS Design Plus, and the MIDAS D shop. Same way in the civil also we have for the bridge engineering we have the MIDAS Civil and the MIDAS FEA, and for the geotechnical also we have the MIDAS GTS and the soil work. So these are the some various product we have. So I just directly focus today, we focus on only on the MIDAS Gen product. So how it is working and this thing. Now you can see this is the geo of the our product. Now I just go to the file and I say new project. My entire thing is generated. According to this, I just go to the one option, file, import, say AutoCAD DXF file. So now I import directly the AutoCAD DXF file so that it's easy for me to generate the all the flows. So I just go to the AutoCAD DXF file. Now here it's asking the path. I just select the one path that is where the exactly my building is there. So I just select this path, the center. If you have the by center line diagram also you can directly take an import nodes only or the nodes and element. I say it's a nodes and element. Nodes means only take the nodes and the element means whatever it is, the slab, beam or the column or the wall. So it's depending upon the which element. Material, first is the material. So which type of the material, still we don't have to decide about the material. So we just click on this dot dot option and we can say add, and in add type of design is concrete. According to the concrete grade you have to select the standard. So as per the IS I select the ISRC, and from the database I select the M40 grade. I just say apply. Now you can see the M40 concrete is applicable. Now if I wanted to change some parameter, that is the modulus of elasticity, Poisson ratio, then I have to only change the standard as a none, and then I can change the whatever the things I want. So it's up to you. Now my unit is in the this way. I just change it so that uh, so I just change this to the any type of the thing. It is the 2.36. I just say I want the 2.5. I can change it to the 2.5 also. So before I that I just save this file. I can say OK also and the apply also. M40, and you can say apply or else OK. Now the M40 grade is generated. Same way, if you wanted to generate the another property concrete, and I say it's a ISRC, and I can say it's a M35. In this way I can generate. And here the bottom you can see the units. If you want you can change the unit anytime, it's up to you. Now in the section, if you want you can add the some new properties. Now I say add. Here some various options are available, so I just go to the any option L angle also. So I have to select the I section Indian standard, according to the you can see the database. So now for the concrete we have selecting the solid rectangle, so I just select the solid rectangle, and I just select the give the property that is the C column, that is the 300 by 600 or else 800 also. It's depending upon you and your sizes. And here you have to say user, because according to the solid rectangular IS we cannot see any database because it's a totally whole solid rectangle. So you have to define manually. I have to say user, and I say it's a zero point 0.3 and the zero point 0.8, that is unit is in meter. So I just say apply, and here in the change offset option is there. If you wanted to change the offset, means now the model is from the center to center. Now if you wanted to change, you can just select this offset also. So by this using of this offset you can change the your dimensions. Yeah, so the 300 by 800 is done. Now the next property we are saying B, that is the beam 300 by 600. So for this reason, my edge, that is the depth of the beam is 600 and the width is zero point 0.3. I just say apply. Now you can see the 300 by 600. Same way for the plinth beam also I can add it PB 300 by 450. So my H is 450 and my B is 300. I just say OK. So I just added the three property 300 by 800, beam 300 by 600, and plinth beam, that is the 300 by 450. It's up to you which type of the property you wanted to apply. Now the next is thickness. In the thickness, I just say for the wall thickness, my wall thickness is 300. I just say add, and here I just say 0.3, and I can say OK. Now my wall and entire the thickness is generated, and I just say close. Now here for center I just select material M40 for the section 300 by 800 and the thickness 300. So depending upon the your layer. So right now I am giving only the center layer for the all member, but if you want you can give for the particular beam, you can give the different layer. Same way for the column also you can give the different layer, and the for the slab also. So according to the your layer wise you can import, and the layer wise also you can give the properties. So no need to define in this way, so it's reduce your timing. One more person is asking about the for concrete section. Can we create the general arbitrary shape? For example, irregular polygon. So for this reason, at the end of this session, I just show you we have one option that is the section property calculator. So in this section property calculator, any type of the section means you have to generate it in AutoCAD DXA file, and that particular DXA file you can import here. So this file you can import and you can use here as a section also. If you satisfy with this answer, then you type the okay or yes, it's okay. Or if you do not satisfy, you just again type exactly what you want from me. So I can explain better whatever the things you want. Now here I just say apply. Now you can see entire thing is automatically coming, but here it's take the other different things, but actually in the real life that is the not case. If you are applying according to the layer wise, the entire thing is considered by the program. Now I just say top view. Now go to the works. In the works you can see M40 grade for the all the members, that is okay. Or else I can see the I can select in the front view only the columns. Yeah. Uh, See, one question is from the Shenoy sir. That is the beams are not correctly oriented. Yes, sir. It is not oriented correctly because I just for entire geometry or entire things I selected the center as a one layer. So program doesn't know for the which property which layer it is considered. So now I changed the property. So how to change the property that I wanted to show you. That's why reason I consider the whole property as a in a one layer. Now I just go to the front view and I select the entire things. Same way now you can see the entire things are there. Just M40 click and drag it to the screen. Now you can see the entire geometry is in M40. Now your beam you wanted to change. So just go to this option, select by plane, and in this select by plane you have to first select the XY plane. Entire your XY plane is selected. Just give the M35 property. Now your M35 property is this. So for the beam, I consider the plinth beam 300 by 450. Now you can see here, just select and drag it from the screen. You can see this beam size and this oriented, because the previously I give that is for the column and now this is for the beam. Now you can see the entire geometry. My first column is generated and this is my plinth beam, and you can see this is the we can say attached from the center. Now I wanted to change the center. So how we can change? So we have to go to this option, structure, say structure type. In the structure type, last option is there, that is the align top of the beam section with a floor XY plan for a panel zone effect. You have to click on this option if you model the beam only, and if you model the slab, then last option also you have to open, that is the align top of the slab, so that what happened, your slab the top is a flush. Now I just say okay. Now if I zoom it here, you can see the entire thing is flush. So that's why we are saying to use this option. So at the time of the designing or analysis, the program itself give the bending moment from the face of the member, not from that center of the member. Only the one point you have to select it. Now according to this, I generate the, you can see this is the my wall is there. If you wanted to draw the wall, I just delete this wall. How to draw that wall, I just wanted to show you. So I just create the some beams. Yeah. So now in this section you can see, yeah. So this is my this two beam means here I want that the particularly my shear wall. So I have to just select these two beams right click element and I have to say extrude. So see the difference between the translate and the extrude. Most of the people are confused in between the translate and extrude. See in the translate we have to copy and move the UI structure, but in the extrude you have to generate the node become a line, or line become a we can say a wall, or wall, or we can say planar became a solid element. So this is only to change the one parameter to the one type from the second type. Now I just say extrude is already it's a line element to a planar element. Source remove means it's a remove the previous that whatever the beam it's there. Element type it's a wall. Grade M40, thickness 300. Membrane and the plate. So what is the difference between the membrane and the plate? Membrane means it's only consider the translation plus your translation matrix as well as your what we can say stiffness matrix. But if you want, if you say the plate elements is take care of the your plate the translation as well as stiffness as well as your rotation matrix also. That's why we require the rotation matrix. So you have to click on the plate element and you have to say height, that is your dx, that is the -3, and I have to say apply. Now you can see my property generated, and here also you can see that is the wall and here it is the beam. Now I just select the entire properties and go to the structure control data and I say building generation. One number of copies is one, direction that is the 3 meter. I just say add and I say apply. At the time of the apply, here you can see the copy node attribute. What is that copy node attribute? This is the function is used. It's because of here we can say I just click out here. You can say if you do not wanted to copy the support point spring, so these are the some options are available. So it's up to you which point you wanted to copy, and according to this point you can copy the UI structure. Same way for the element also, means in the element if you have already applied the some beam and releases as well as the beam and offset, beam load, pressure load, any type of the loading you are applied, so it is also copied. If you unhide or if you uncheck this option, it is not copied. So this is the use of this copy element attribute or the building element attribute or else node attribute. Yeah. Now for this above section, I just click here and I just select the only the top view. Now you can see entire my beam is selected. Now I just change this size to the 300 by 600. So within a few seconds, means just select the element and from the tree menu you have to just click that property and drag it to the screen. You can change the particular property. No need to go to the another soft point. And whatever the things you want, you can see here. Now next is we are going for loading, and then same pattern or the same model we replicated to the above floors. So before we are going to these points, we have to define the loads. Go to the loads, you have to say static load case. Now here I define that is the static load case. Which type of the loads are there? I just say that is the dead, or else we can say self self weight type dead add. Okay, so in this section only the sulfide is considered. SIDL, that is a superimport dead load. We are considering this superimport dead load because of the dead load, the SIDL, that is the floor finish, that is the after you applying the, you can say floor finish means it's depending upon the you are we can say after the concreting which type of the loads we are applied in a dead form, means that is the floor finished wall load, that is entirely coming into the SIDL case. So that's why we are saying it's a SIDL, type is dead load add. But it's fully depending upon you also how to do the entire thing and these things. Okay. And once I did these things, sorry for the guys. Actually, I have not seen the your questions. So the Chennai sir is asking the one question, that is, how can we flush the column correctly at a junction? And the one more, that is Amit Sanap. He is asking about the what if we want to change the orientation of a one of the column. So I just show you how to change that orientation also and the flush of the member. First of all, I have to just define these things. SIDL is okay. For the live load, I just say LL type live load add. Earthquake EQX type earthquake add. Y earthquake add. Same way wind X type is wind load on a structure. I say add. Same way for the Y wind load on a structure. I just say apply. Now the next is, yeah. The next is I just wanted to show you how to change the orientation of the particular column. So now here you can see this is the one column. So in this column I wanted to change to the a 90-degree. So I just select this particular column and I right click on a screen element and I have to say change element parameter. Okay, first select the column, whichever the column you wanted to change the orientation. First select the column element, change element parameter, and then you have to say element local axis and the beta angle, that is the 90-degree, apply. Now you can see this column, the orientation is changed. In this way you can change the orientation. Now one more question is asking by the Shonai sir, that is the how can I flush the column and correctly at the junctions. So in this property, at the time of the section property, if you model this any members, I just say modify. Now here it's, you can see in the center to center option is there, and in the change offset also you can see center to center. If I want that particularly this portion, so I have to say left center. So if I say left center and I display option, now you can see the center is shift here, or if you want you can use that user defined also. So you can give the exactly value and you can flush it. See, up to you the which type of the property you wanted to use. Or else you can use these options also, that is in the boundary, beam and offset. So in the beam and offset you have to give the dimension. According to the dimension your geometry and entire thing, the offset command is used. Now I moving further ahead. For the beam, if I wanted to apply the loading on the beam, so I just show you for the one particular beam how or which type of the load we can apply. I just select the one member and I go to the load and I can say element. Yeah. Again, the sir is asking the one question, that is uh, if you select the extreme fiber, does the program automatically flush the column, or do we need to do the for each column individually? So actually, sir, that you have to do the individually, because if the column sizes are different and it is the place in the different place, so whether in the which direction you wanted to flush, that you have to manually do for every junction. It is not the one command flush the column in this way. So you have to do the individually and you have to give the individual values. Yeah, if you go through the section property, then you have to define the section property. So the Ramnath sir is asking about then do we need to define the separate property? Yes, sir. If you say the new property, in the new property, so you have to define the new property. Otherwise you can use in the boundary, that is the beam and offset. So you have to give the beam and offset, and according to the offset it is take care. So no need to then define the your, what we can say, your properties. So program itself take care of these things, and according to the your same property it is moving further. It's the same as this option is on. Okay, so I just show you how to use this option. So at the end of this I just show you how to use this option, because I just wanted to tell you the further things also. So it's about the modeling things only, so I show you how to use this offsets command. Now here I just show you how to give the loading and these things. So in the loading I just select the one member and go to the loads, and I say element. In the element is asking the load case name, sulfate, SIDL, live load, earthquake X, earthquake Y, wind X, and the wind Y. So I said SIDL. Now here is asking the uniform load. If I want the UDL throughout, I can say uniform load. I just say concentrated force. So it's take care only the point load at particular junction. We can say X1. So I want that 1 meter, and the second one at the 2 meter. So that is my load is -10, and the second one is -15. And if I say apply, sorry, it's absolute distance, apply, and if I say close display, now in the display you can see that point load are defined here. So it's up to you how to define the point loading. And I just delete. If you want to do change, just right click and say table. In the table also, if you want, you can modify. Now here you can see the P1, that is the 10. If you want, I can say I want this is the 5, and I want this is the 25. In the table I just change it. Now if I go to the model view, now here also you can see this is the 5 and this is the 25. So according to this you can use this option. And if you wanted to delete, just click here and say delete from the your keyboard. Now your these things are gone. Same way for the other also, you can see this option is there, typical. You can say uniform load, 2 triangular, single triangular, 3 triangular. So these are the some options are available. Okay. So for the shear wall junction, I just say you can see this is the shear wall. It's a shear wall junction. No need to do the anything else. At the particularly at the end of the column, end of the beam or end of the shear wall, your next column or next beam is started. So no need to do the further things. Yeah, we have the option to generate the floor load. I just show you about the floor load, how to generate the floor load. So before that, I just tell you how to give the loading on only on the beam. About the floor load, I just show you the later on. So it is only the part I just show you how to apply the loading. Same way the hydrostatic pressure option is there to apply the triangular loading into the plate element, not only the column, into the plate element. Yeah. So this is the these things. Now the one more question is asking by the Deeptesh Patil sir. So he is asking the one question, that is the, does the program determine the sulfate itself, or do we have to define the sulfate factor? Yes, we have to define the sulfate factor, that is the -1 in the gravity direction. According to this, whatever the sulfate or the size or the density we are defining, according to that, or whatever the element we are defining, according to that is take care of the program. So for that reason you have to go to the sulfate, and you have to say load case, I want the sulfate into this particular load case, and Z I have to say -1 and add. So you can see one sulfate is now, whatever the element you draw, the program itself consider the sulfate. Now at the Chetan sir is asking the one more question, that is the at the end of the shear wall, is there any need of the column? No sir, it's no need to generate the column. That's why in our model also you can see there is a no no column near the shear walls. So it's itself the huge concrete member is there. So no need to generate the column at the end of the shear wall. Next, I just select the beams, that is a 300 by 600 and 300 by 450. I just select, go to the element, SIDL, uniform load, and I say it's a -10 loading. So it's depending upon you. Now I did for the all the members. If you want, you can select the particular one member, and then also you can select. In this way, you can see UDL is generated. Now one more question asking by the Harish Patel, that is if we added the more member, then it will be considered the self-fed automatically. Yes sir, if you draw the member, it is considered by the program the self-fed. So it is not that at the time of you are applying the self-fed factor 1 only that much it's considered for the self-fed. No, at the end whatever the member you draw, it's considered the self-fed. And again that Shonai sir is asking, there is an odd junction at the end of shear wall. How do we ensure that the length of the shear wall is up to or at output face of the beams? Okay. So generally what happens sir, it is the basically a line diagram. So at the end to end, now means you can see here, I just select the one. Yeah, now here also you can see this is the, yeah, now here also you can see this is the line diagram. In the line diagram, this is the my shear wall. You can see this is the shear wall. At the end, everywhere or anytime you can attach, or just in the junction also you can give the beam junction, beam joint. So according to the beam joint, you are take care by the program itself. Whatever the movement and these things are coming is take care by the program. No need to generate the any other things. So in this direction also you can apply the your this type of the loading. Now I come to the my modeling. Yeah. So now this is the loading is done. Now the next thing is I am applying the surface load. How we can apply the surface load? See, this is the my podium floor in sorry the plinth level. In the plinth level only the staircase loading is there. So we apply the only the staircase loading. Okay, the sir is asking the beams are at say 3 meter center to center, but the wall should be 3.3 meter long. In this model, then wall is 3 meter long. Yeah, so it's so depending upon you. If you consider the outer face of the member for the actual length of the column, then your the room sizes is increased. So your might be your length of the member is also increased. And the beams are at the say 3 meter center to center, okay, and but the wall should be the 3.3 meter long. In this model, tell what is the 3 meter long. So wall is, yeah sir, in this model the 3 meter long we are considering the your shear wall. If you want the 3.3, so you have to generate the beam according to the 3.3 meter high length. Otherwise you can give the particularly we can say break at particular nodes. So whatever the exact length you want, you have to first of all generate particular that much length of the beam, and for that particular beam, you according to that you can generate the your wall. Yes, sir. Two more nodes we required for the generate the model. Otherwise, we can say the two more beams is required. First beam break at the one junction and the second beam at the end of that shear one. So this two beam you have to generate it part and then you can apply the wall load. Now in this above floor, I can say I just wanted to generate the floor load. So go to the loads. I have to say assign floor loads and I have to say define floor load type. Now I just click here and I just say typical. In the typical, we can say self-weight. So self-weight of the slab I have to consider. So generally, if I consider the self-weight, that is the it's a normal 125 mm thick. So what is the density we have to consider? So according to the 125 thickness, the my self-weight of the slab is 3.125 kilonewton per meter square. SIDL, that is the minus 1.25, and my lie load is minus 2. So that is add same way sunk 200. So my sulfate, that is I consider the 200 thickness slab. So it's a minus 2.5 SIDL. In this SIDL, I have to add the filling load also. That is a 200 filling load. So 200 into 2, that is the 4 plus my 1.25. So I can say it's a 5.25 load I can consider. Okay, so sub beam weight, it is a sub beam weight, it is not a slab beam weight. In the sub beam weight, if the any sub beams are coming in between the slab, it is automatically take care by the program. So if you model the i- so if see the some two or three panels are there, and if you connect by through the edges, so in between also generate the sub beam weight. So no need to click on this option. So you have to just click on the one option, that is the sub beam weight. No, no, it is considered the sub-beam weight. According to this, it is the use. Now, where I just say SIDL 5.25, lie load is 3. Okay, so, okay, now I just say the sunk 200, add. Now, same way, if I want to staircase, that is the 175 thickness. So, sulfate, I consider the 175 into the 125. Sorry, 25, that is a 175 into 25, so we can say it's almost 4.375 minus 4.375, and my SIDL, that is the we can consider my step load. So the my second SIDL I consider 1.25 plus my this way step load, that is the step load I have to add it, that is the I can say it's a 3, so we can say it's a 3.5, and my lie load is a 3. Now one more good question is asking by the Mr. Chetan, that is the why the first column of the sub-beam weight is activated than the other. So if you want you can add it in the other also, but if you do not want then also it is fine, because it's up to you. So if you click on the other options also, it is considered in the particular other junction also, because if you click on the one option, that is the sub-beam weight, so in the sulfate itself consider the that is the so according to that load, it is automatically take care by the program. No need to click on the other options. If you if you do not want, then you have to click the sulfate off option. Now it is the generated in this way. Yes, sir. It's a mean by the subtract. Means generally, if the hidden beams or the in between the beams are coming, so it is take care by the programs, and at the face of this, it's reduce the US sulfate. So generally, we are considering this at the time of the sulfate calculation. So for that reason, in the sulfate calculation, I have just click on this option. Otherwise, in the other uh, yeah, if you wanted to, okay, the mother server is giving the good suggestion, that is the sir, Shanai sir and the others peoples. So we just do the one thing. You just note down the all the question answers, and at the end of this session, we can do the question and answering session, because if in the in between you are asking the question for the others, might be they cannot understand the entire thing. So you just note down all the points, what are the points you have, and at the end we can do the our question answer session. So now so I have to select the one level. So I just go to this option XY plane, I select one plane, and I just say activate. Now my this is one floor is selected, and it is not coming because it's a shear wall is there. Now this portion is sunk, this portion is shear wall, sorry, staircase, and the other portion is typical. Now how do I apply? So just go here, I just say assign floor load, assign floor load default, load type my is typical, two-way loading if I wanted to consider. Just go to this option, first, second, third, fourth, fifth. Now just close. You can see here floor load display. This is the load is there, and this load is take care by the program, because if you consider the two-way, the shorter span is considered the triangular loading, and the longer span is considered the trapezoidal loading. No need to define in this way. If you want to do the one-way loading, we have the one option, that is the one-way also. Polygon centroid is a good option if the irregular geometry is there. So according to the irregular geometry, the program itself consider that the according to the CG, if you see in this box, according to the CG is transfer the triangular loading to the connecting member. And the last option, that is the polygon length. So according to the polygon length, it's calculate the area, divide by the area, and it's transfer the UDL to the connecting beams. Now it's a typical loading. Same way I just click first, second, third, fourth, and here. So, oh sorry, first, second, third, fourth, and the fifth. So loading is there. I just click on the four nodes. If you want, you can click here also, from this pattern to this pattern. Program generate the these things. Now for the this particular one section, and this I have to say it's a staircase one way. Now in the first staircase and the one way, if I select the this particularly edges, so what happened? You can see the load is transfer here. But if you have the one option, see in the box, first node, second node, third node, fourth node, it is asking. So according to this, we have to define, and same way asking the angle. For the vertical angle, we have to say 90 degree, and first selection, second, last, this, and the this. Now you can see the loading is transferring particularly this two direction. So generally in this program, what happen? It shows not shows the only the kilonewton per meter square value. It shows the entire value. Whatever the total value is there, it shows in this way. And for the sunk, I consider here, and I consider the 0 degree. Now if you wanted to change the some property, just right click here and say table, and you can see here in the table or whatever the property you want, you can change here. And same way if you wanted to delete, the delete here. You can see the noded area, loading area, these options are there. Just right click and say find. From the nodes also you can find out the entire things. So this is also the good option is available. So just go to the nodes. Now see in the staircase, see in the particularly this area, I do not want the loading, or so I have to just go here. I have to see the nodes. Here you can see 75, 77. According to this, some nodes are there. Yeah, 75, 90, 93, 94. Okay, so I just go to the floor load and I can say 75, 90. 93 and 97, this is. So if you want, you can delete from the here also. Now if you wanted to change the loading, if you consider the one-way loading, here the option is there to change the angle. So you can change the angle from these options also. That is the 90 degree you want, 45 degree or 0 degree. So this is also the option is available from this tabular form. So what are the things you want? You have to first see the nodes, and according to the nodes you can change the staircase loading, whether it is in the which direction. So this option is available. So now whenever you are the file is imported from the any AutoCAD and this thing, so you have to just go to the structure and say check duplicate element. So if you are saying the check duplicate element, in the below zero element have been deleted, so that means you have not duplicated any element. If any duplicate element is there, so you have to first check, then you have to perform for the loading. Otherwise in the loading you can see the duplicate element found, so this type of the error is coming. Now my entire geometry is generated. Now I just copy this to the particular floors. So I just select this particular floor, and for the this I just go to the control data and I say building generation, and I generate the some 10 floors with the height of 3 meters, and rest of the property I considering the same. Now here you can see this type of the property. So this is the my building. According to this, whatever the things you want, you can add it. And at the end also, if you want, you can go and you can change the geometry also. This the terrace loading also. You can just go here, and in the below you can see this is the top floor. So this is the my top floor, 152 to 165. I can change this property for the terrace loading also. So you have to generate the again that group, and from the group you can change the property from these locations. So these options are available. And if you see the rotation, so here the rotation, dynamic rotation option is there, so you can see. So it is easily rotated, and this is the top plan. Now my entire geometry and this thing is done, and we are moving ahead for the my column, sorry, the wall, and then fix the support, and then we go for the lateral loads. So before we are going for the lateral loads, so we have to see first, go to the display option, you have to say element and the wall ID. So this is the one and this is the one. The wall ID should not be a same for the two walls. It is same for the only for the one wall. If the two walls from the from the geometry, it's the same wall is from the geometry. So it's take it's average the stresses. So it's the might be you are getting the wrong answer. So for different wall ID is important. If you are using the ETAB or the other software, you know that the peer label or this type of the wall ID is very important for the designing. For the analysis it is okay, but for the designing it's very important, because the particular wall ID we are giving, so that much the length is considered for the design. So changing the wall ID, just go to the element and say change element parameter, say wall ID. So if I want this, I just click here and I say apply. Same way, if I click here, automatically two number is there. I just say apply. Now one and the two. This is my the wall ID. And if I go to the floor front view, I select the base point, right click, boundary, and I say support. Right click, boundary, and I say support, and I just say Diol and the RL, apply and the close. Diol, RL and the apply and the close. So from that Diol and the RL, so you can get directly the entire things. Whatever the things are there, it is automatically coming. So automatically it considered by the program. Now the what is the next step? So next step is the generation of the diaphragm. Just go to the control data and you have to say story, and in the story data you have to say auto generate story data, and the entire the story is automatically considered. 5% eccentricity is considered for the plant dimension for the seismic accidental for the 5%, and the for the wind eccentricity is considered the 15%. Okay, these things. And one more question, that for the column change size changes, so you have to particularly select the one property, one member, and from the tree menu you have to generate the property and you have to just drag it to the screen. According to the UI drive, that particularly property is assigned to that member. So for each and every layer, or we can say this layer, you have to select the some, first select the element and then drag it to the screen. Now I come to the here display, boundary, and in the last option you can see story diaphragm. You can see the automatically story diaphragm is generated. If you want to delete the diaphragm from the particularly some areas, so you have to select the some point, this area you do not want. So you have to select this particularly this node and this node, and then you have to say boundary and diaphragm disconnect, and you have to say apply. Once you apply, from this particular point your diaphragm is not taken care, so in this particularly location the wind load is not governed. This is generally used for the showing the opening and these things. Now next is loads, wind loads. I just click on the wind loads and see the wind loading and these things. Before going to the wind load, we can see so which type of the parameters. So go to the loads, wind loads, add wind X, wind load code. I just say one IS 875 1987. Standard method and the gust factor. Again, the standard method is a normal method, but for the gust factor, you have to calculate the G value, and then you have to define it here. Otherwise, you cannot define the values. Then basic wind speed, I can say the wind speed is there. It's a yeah. So basic wind speed is 47, and my terrain category I consider the 3, and building class C. Automatic calculation general building, that's why the my risk coefficient is 1. If I want in the one direction, x direction only, so I say x direction 1 and the y direction 0. So whatever the value I am getting in the y direction, that is the automatically coming to the 0. Then I say wind load profile. You can see the profile, you can see the story share, you can see the overturning movement, and this is the story force. Now I just click on the make wind load calculation sheet. You can see the entire calculation. Wind load F is equal to P into area plus F dash, P equal to CP windward leeward PZ, F dash CF dash into frictional area into PZ, and what is the PZ? 0.6 into VZ square. So entire things are calculations are there. You have to just go there in the bottom. You can see the entire things. Story force at particular floor, story shear, how it is calculated. The entire thing is there. Now I just say apply. Same way I can here I can say wind y. Only the my scale factor x direction is 0 and for the y direction is 1 and my entire things are same. Now I wanted to see the values. Just go in the tree menu, wind load and say display. Now if I say it's this diagram, so here it shows the values, but for the your better understanding I just change my background. Now here you can see the entire value and these things are there according to their value, and it is directly applied to the your CG, that is the diaphragm. According to the diaphragm, whichever the point is connected to the column, it is directly transferred to the vertical element. So this is the use of the diaphragm. Same way right click I say display. Now you can see the direction is changed. Now according to this also you can identify how to consider the wind X and the wind Y direction. Now next is earthquake. I just go to the seismic load. Before I go to the seismic load, for the seismic load we have to define the mass source, that is the seismic weight, how it is calculated. So how much participant you want for the calculation of the seismic weight. So I have to just go to the load to masses and I have to define that is in which direction I want the mass direction. I say XY, which type of the load. So load cases for the self-weight I want 100%. For SIDL 100%, and for the LL, that is I say it's a 0.25 because it's a residential building, so my lie load is less than 3, so I can consider the 25% my lie load reduction for the calculation of the base shear in a seismic according to the seismic criteria, or for more than the 3 kilonewton per meter square my lie load reduction factor is 50, means 50%, that is the 0.5. So that much you have to value, you have to define here. Now whatever the value you are getting, that sulfide is considered 100%, earthquake SIDL 100%, and the lie load is 0.25%. Now go to the seismic load. I just say add earthquake 1893 2002 seismic zone. I consider the 0.16, soil type 2, importance factor this, damping 3. Now for the fundamental period calculator, just click on the period calculator. According to the period calculator, you can see the x direction period. So T is 0.075, H raised to 0.75, and these are the some formulas are there according to the infill and the without infill according to the formula. Same way in the T you can see second formula 0.085 H raised to 0.75. This is the formula according to the your steel, for the steel calculation. So these are the some formulas are there. If you want you can change the sizes. So if I consider 3, it is the editable format. If you want you can change the sizes, and according to this your x direction and y direction calculation is there. Seismic load direction one direction, in the other direction say 0. Accidental eccentricity, if you want positive negative you can consider, otherwise for the normal calculation you can say none. Torsional amplification, we can say inherent eccentricity. So that is means what if the your earthquake is 5%, the torsion is coming 5% of your plant dimension, so your torsion is added into the structure. So for added into the structure, you have to click on a inherent eccentricity. Otherwise, your torsion is not calculated. So if you want the torsion calculation, you have to add in this option, that is the inherent eccentricity. And the story, this some small options are available. These options are available for the soft story calculation. Generally, what happen in the soft story calculation, you are above floor, you have to design according to the 2.5 times of your for the your earthquake load. So in this case, you can add your earthquake load in a particularly X, Y, Z direction. It's according to you which direction you want. So you can add it in these directions. So I just say seismic load profile and go to the seismic load profile. You can see the profile. Same way, if you go see in the your value in the table formula also, overturning moment, story shear, and the story force, entire things are there. Now how it is calculated? Just click on the seismic load sheet. You can see below, that is the seismic zone 3, soil type, importance factor, AH value, that is the 0.0507, AHY value 0.0359. Same way, what is the my seismic load? So according to the mass source, that is the 100% SRDL, 100% your dead load, and the 50% you are this thing. So according to this, it is calculated. Yeah, I just say close. I just say apply. Same way for the earthquake Y. Same things I consider. Only the X direction is 0 and the Y direction I consider 1. And I said okay. The entire rest of the things are same. Same way here also you can see, right click display. You can see the forces, and right click display for the Y direction. You can see the forces. So first of all, you have to see the forces. If the forces are coming in perfectly, then it is fine. Otherwise you have to change the your entire things. Yeah. Now the next is moving ahead for the our analysis. So in the analysis or in the loads, I have to click on the dynamic loads. In the dynamic load, it's asking the RS function, that is the response spectrum function. Click on the response spectrum function and just say add. Once you say add, here you have to click on the design spectrum, that is the spectrum analysis. You have to click on the design spectrum. In the design spectrum, asking the code, I just say 1893. Soil type I have to select, that is the 3, sorry, seismic zone 3, soil type 2, the rest of the things are same, and I just say okay. So you can see this period versus the structural data it is generated, that is the spectral data, or we can say acceleration. It is the automatically calculated by the program, and I have to say okay and the close. Now my 1893 this code is generated. Now I have to generate the RS load case, that is the which type of the load we have to apply it. So load case name we can say spectra X, X, that is the XY. Auto search angle, if you doesn't know the principal axis, then program itself calculate the auto search angle. The model combination control, here you can see which method you want, SRSS, CQC, ABS or linear. It's up to you. IS 1893 2002, according to this code is take the value. Okay, the Harish Patel is asking the diaphragm disconnectivity. Yeah, I just show you at the end of this analysis program, because whatever the doubt you are facing in the only in the analysis, that much thing we can see after this analysis. And for the design, afterward we start the design. Now I just go to and I just say add. This is my spectrum X is generated. Same way, if I go here, I just say spectra Y, and my angle, that angle is 90 degree. Now here I have to select the angle 90 degree and I have to say add. Now this is for the spectra X and the spectra Y. And what about the dynamic analysis? So go to the analysis, say eigenvalue, and now you have to say number of frequency 12. Initially we can consider the 12, and we have the two methods, eigenvector method and the rich vector method. So I said eigenvector, Lancaster's method I selected, number of frequency 12, and okay. So whatever that we did, you can see entire in this tree menu. No need to go everywhere. You have to just go and double click on this option, and the entire thing is mentioned over there. Yeah. So now up to this, my entire geometry analysis and these things are over. Now the next step is analysis. Before I'm going to the analysis, I wanted to tell you I wanted to tell you about the question answering, about the modeling part only, not other the things. First of all, I explain the things about the Ramnath Shenoy sir. So you are asking about the sub beam width, okay, in the loading. Yeah. So you are asking about the sub beam width. Yeah, it is the sub-beam weight means what? In the secondary beam, if the in between the member beams are coming, so or at the junction, so the center to center is take the panel. So if you wanted to reduce, if you do not want to consider this much part, so you have to click on the sub-beam option. So it's only take the face of the member. So if you do not click, then it is a consider from the center to center. So it's up to you. If you wanted to take, you can consider, otherwise you cannot. Now for the next point, that is diaphragm disconnection. So generally this is my one slab, and if I just on the my diaphragm, my CG is this way. So I do not want this particular point in the diaphragm, means I can say this is my opening and this is my opening. So I don't want these two 4 points. So I just click here, go to the boundary, and I can say diaphragm disconnect. If I say diaphragm disconnect, yeah, if I say diaphragm disconnect, I can say apply. Now you can see my CG is shift and my this point is not considered for the diaphragm. Means this particular portion is not considered for the your we can say for the wind calculation. So this is the use of the disconnect diaphragm. If you wanted to add, you have to say delete, apply, the close. So now you can CG is again change. Now one more thing. Yeah, it should be only the tick on the sulfate. If you want to only do not wanted to calculate the sulfate, then you have to click on the sulfate. Otherwise, for the other also, if you want to do not want to increase the panel size, so you have to click on this option, that is the sub panel sub beam weight. So it is not considered the particularly that weight. It is reduced it and then it's give the value. And now that Pramod Berry is asking the one more question, how to change the size of the member. Yeah. So for the changing of the size of the member, so particularly see this is the one my building. So if I wanted to change the size, first of all I have to generate the some property. So I just generate one property for the rectangular, that is the C 450 by 450, and I can say user, it's a 450 by 450. Okay, so here it's 450 by 450. Now I just click here. I just click here. Once I click, and from the my tree menu diagram, I just click the particular property. Now you can see my sizes is 450 by 450. In this way, I can change the floor size. Okay. Now one more question asking by the Harish Patel, that is if you do not want the diaphragm in the staircase area, then how to do it? So for the staircase area, if you model the staircase area, then you can consider that is you do not want that diaphragm. But in the particular floor area, if you do not want that particular things, so you have to just go in this way. I just select the one floor. This is the one panel. So if you do not want this particular nodes, so you can see this, I do not want this particular two node, because these two nodes are connected to this slab, and these two nodes are connected to this slab. So this point we cannot consider. For these 2 points you can right click and say boundary, and say diaphragm disconnect, and say add. Now so in this way you can see my diaphragm is here, because in this point it is the my floor beams are there. So this area is taking the part of the my that loading, but for the in between you cannot show. Yeah. Now one more question asking by the Vijay Khilari, that is how to change the floor to floor height after the building generation. Okay, so I just show you how to generate the floor to floor height. Then I go ahead. Okay, so I have to select, see, I just select this particular this row. In the 3D form you have to select it. Now you can, I just zoom it here. I just select in this way. Now I just want this floor. Now it's a 3 meter. I want the 4 meter. So I just click here, right click, nodes, and I can say translate. So in the translate, so Z direction I have to say 1 meter or whatever the height you wanted to increase. So increase by 1 meter. So my column height here it is the 4 meter. So I have to say apply. Now you can see my column height is changing. So this way also you can perform the your modifications. Nodes, translate, copy, sorry, it's not a copy, it's a move into the 1 meter, and I just say apply. Now you can see my column, this particular height is 4 meter now. So this is the things you can modify. And now one more question asking by the Ramnath Shenai, that is how do you add the mid landing beams? So for the mid landing beam, I just show you how to add. I just select the one floor because I just show you in the one floor so that it easy for you to understand. So I just select this beam, right click, element, and I say translate. So I can just say move or the copy. If I want that mid landing beam or the floor beam also, I can say copy. And at what distance? I just say minus 1.5. And if I say apply, now you can say this mid landing beam is generated. In this way also you can generate the your mid landing beam. So only that connecting member is required. So right now I just show you how to generate the in between the panels. Now next question is asking by the Pramod Berry, that is how to insert the sub members, that is the secondary beams. Yeah, so for the sub members we have the good option. So generally first of all you have to just generate the some nodes, or you can say yeah. If I want to generate the some secondary beam here, I just go to the nodes and element, create element, general beams. I can select the some grades. I can select the properties 300 by 450. First click here and click here. In this way you can generate, or else you have to generate by applying the nodes. So first of all you have to create the some nodes. For the creation of the nodes you have to select the some property, right click nodes, and say translate. Translate it into the y direction, that is the -2. I just say apply, and if you see the nodes, here some nodes are generated, and according to this node you can connect. So I can go to the create node and I can say here to here. Now my this node is generated. So in this way also you can perform. It's up to you how to generate the secondary beams. Now next question is how to define the floating column. The same way you have to generate the one nodes. We can say, see here one node is there. Okay, so I just select the one point, right click, element, I just say extrude, node to line element, M40 sheath 450 by 450, and my height of the column, that is the 3 meter, and I say apply. Now here you can see column is generated. Only the thing is you have to break this particular member at particular joints. So you have to go to the divide elements. stub column also for the floating columns from the floor beam. So in this way also, if you wanted to generate from the floor, so you have to create the plate element and then you can generate it. So it's up to you. So how you can want to perform it. So in this way also you can perform. And now the next is asking the how to create this stub columns or the floating column from the floor to frame. It is okay. Now for the Chetan is sir is asking the one more question. Any boundary condition apply at the origin of the floating columns? No sir, no need to generate the any that boundary condition. Only the thing is that you have to we can say uh, uh, neglect the diaphragm effect. If you consider the diaphragm effect at particular point, so it's give the wrong result. So if you are using the other software also, do not consider the diaphragm effect where the your floating column is started. Now the Ramnath Shenoy sir is asking, can you span the one-way slab of staircase from the floor beam to mid-landing beam? So no, for that reason we require to model it the accurately, because in the inclination we cannot apply the one-way or the two-way loading. So we cannot perform this inclination load. Chandaru, yeah. Sir is asking the one more question. It is possible to place a beam over a mid or the shear wall. Yes, you can place. You have to just create the beam and just say convert to the translate to the at the mid landing. So in this way you can perform. So I thought for this today is in the PT slab. Oh, sorry. That Pramod Beri sir is asking the one more question. That is the it is possible to design the PT slab. That is the post tensioning by using the MIDAS. So actually for the PT we cannot model the slab. Only the beam option is available. So you can design or you can consider the losses, various losses. And if you know the losses and the load, according to the load, you can directly get the that bending moment and this diagram also. This is also the good option is available. So right now, sorry for the inconvenience, sir. So today we just stop this our webinar for the up to the analysis part. For the designing, tomorrow again we continue with this our design part. Right now, whatever the doubt you have only for the up to the analysis part, we can do today itself only, uh, because for the analysis and the design I required the more time, and for the continuation of this 2 hours is it not good. So okay, so can you account for the crack section property? Yes, sir. This option is available for the slab analysis. According to the IS, also you can see if you already install our IS version 1.2 or now the latest version is there 2.1. You just download from our website. Also, the new feature is added in the MIDAS Gen 2015 version 2.1. So you can use our this version. And if you wanted to use this version, you just take the some protection key ID from our office. Yes, sir. Property modifier option is available. So one more thing, the Madhav Kale sir is asking the one question, that is the crack section property. If you already download our software, so in our software, in the C drive program file, Midas Gen, and in the manual or in the tutorial, you can see the crack section entire things are there. So how it is calculated and how it is there, you can see. Now the next is asking the Madhav Kale sir, it is the which codes are available in the program of the Gen. We have the various codes are available. It's up to you which code you wanted to okay, so which code you wanted to perform is up to you according to the your uses, or according to the license you purchase. You see the various codes. Now again that Ramnath Shena is asking the property modifier. Yes sir, we have the property modifier. Just go to the property and say scale factor. In the scale factor you can see section stiffness scale factor, wall and the plate. So you can modify for the section property for the beam and the column, wall for the particular wall, and the plate for the plate elements. Now the next step, the question is asking by the uh, Chetan sir, that is how we can release the condition for the secondary beam. So you have to just select the one member and just go to the boundary, and in the boundary you can see the beam and release. So in the boundary we have the beam and release. In the beam and release, MY is the measure axis for the beam and the MZ is for the column. So you can release in the both direction, or if you want you can set the percentage also. So you can release it. And the next step, the yes, sir. For the purchasing of these things, you have to talk our manager, that is the Mr. Tulsi Bala, for the your if you want the other course. And for the Ramnath Chennai, sir, the release torsion for all the beam in a floor, yes, we can say it's a MY, MZ. These options are available. According to this, you can use this option. And for again, the Pramod Berry is asking it is possible to design the foundation like a raw footing by the using IS code. Yes, sir, this option is available. You can use the combined footing also, raw footing as well as the slab, flat slab also by with the drop panel or without drop panel. And the Vijay Kilar is asking, is there any measuring tools for measurement? Yes, sir. In the query, just go to the query. We have the query nodes. In the query nodes, you have to just select the two nodes and you can see the dimension in the message window. Same way in the element also, you just click the element and say right click on the element. If you say this way, in the bottom, you can see the dimension, the length of the member as well as the weight also. So, sorry, sir. Today we just stopped this our webinar session. So tomorrow again we start for the session with the some the whatever the doubts you have. You just ask me tomorrow. So we just set another schedule and we'll send you the link. Same way we conduct our continue our next session. So in the next session, whatever the only the design parameter and the analysis result we are shown. So whatever the doubts you have regarding the modeling and this thing, you just mail us. Our tech support ID is techsupport@midasIT.com. Whatever the doubts you have, you just mail us. We solve your query. Uh, yeah. Thank you, sir. I just talk with the sorry. Cannot. Yes, sir. Whatever the recording we do, we send you the recorded copy to you, and whatever the things are there. And sorry, sir, I just stopped this today itself. So tomorrow again we start for this. And yes, sir, I'm getting your question. You are asking the so many questions. So, yes, sir, I just copy entire things and I just means give you the call, and I just with the help of the call I just solve your problems. You just give me the 5-10 minutes. Within the 5-10 minutes, I call you, the Mr. Amit sir as well as the Shanai sir also. We discuss on this on the phone and we can solve your queries. Okay, thank you, sir. And tomorrow again we reschedule our design and the analysis part. Thank you.